Hello all, let's start section 5.2. 5.2 is verifying trigonometric identities. What does it mean? It means in this section, mainly you are working with the problems, but what using section 5.1. All those basic identities or fundamental identities that I noted for you in section 5.1, you are using those in section 5.2. What does it mean verifying trigonometric identities? For example, they give you an equation like this, correct? I'll just write here an equation, and they give you that equation and they're asking you to check if this equation an identity or not, correct? For example, let's say maybe tan squared x plus 1 equals 1 cosine squared x. I don't know if this side is equal to this side, if both sides are the same, correct? That's why they are asking you to verify if it is an identity, if the left side of your equation, which is tan squared theta plus 1, this is your left side, it's the same as your right side of the equation, 1 over cosine squared x, correct? Verifying means to check if it's an identity. To check if the given equation is an identity. That's the meaning of verifying trigonometric identities. To do this, to be able to do this, there are 5 steps noted, 6 steps noted in your book, very in detail, but I'll give you here like very simple 5 steps. I'll brought a little bit of changes in it, make it simple for you. Work with these steps one by one, correct? Step number 1. Let me give you steps. Step number 1. Start with hard side. One side will be always hard, complicated. Hard means complicated side, correct? Start with that side and try to rewrite it in a simpler form, correct? And try to rewrite in a simpler form, correct? That will be your step 1. Step 2. If you are dealing with fractions, get one single fraction or get a single fraction. For example, they give you one fraction here plus another fraction. Try to combine these 2 fractions in one single fraction. That's the meaning of step 2. Step 3. I think I did an example like this in 5.1 for you. Step 3. Rewrite the terms in terms of sine and cosine if possible. correct? Step number 4, use known identities. Use known here means the ones that you learn in 5.1. Use known identities. And in your step 5, try to work, always try to work, I can say 98% of the time, try to work on just one side. I'll make it bigger to remember one side. Do not work on two sides. Only work with one side. Correct? These are the steps. If you follow these steps and you remember your identities, then it's really easy to do these. Actually, I can name it also proofs. Here you are doing proofs, not the actual proof to prove an identity. You are proving an equation, that this given equation is an identity, correct? Example number 1. Verify that the following equation is an identity. What is the equation that's given to you? Cotangent plus 1 equals cosecant theta. Sorry, this is also cotangent of theta, not just cotangent. Cotangent doesn't give you any meaning, right? Cotangent theta plus 1 equals cosecant theta times cosine theta plus sine theta. In this example, you see one of the sides are really easy. Cotangent plus 1. It's really kind of in a simple form. But look at the right side. The right side, cosecant theta times cosine theta plus sine theta. You have to work with that one to change it. Actually, what's your goal? You are changing the right side, which I underline with the red, this side. You are changing this to what? As a cotangent plus 1. You have to work with this and you will see if it is an identity. If it is an identity, this equation, your right side also becomes cotangent plus 1. Correct? Let's work with the some professors, they write the left side always, then they use an equal sign and they put a question mark. Is this equal? It's better to just leave this and just copy the right side, work with the right side and see if your right side becomes cotangent theta plus 1. Rewrite the right side, please. You have cosecant theta times cosine theta plus sine theta. The first thing that I see, okay, inside the parentheses, I have everything in terms of sine and cosine. The outside is cosecant. What I'll do, I'll change this one also in terms of sine and cosine, correct? I know cosecant theta is 1 over sine theta. 1 over sine theta. I will multiply this with cosine theta plus what? sine theta. Okay, multiply. When you multiply a fraction to a term, of course, you multiply only the top, correct? It means you will end up with cosine theta over sine theta. 1 times cosine theta gives you cosine theta over sine theta. Positive times positive gives you positive. 1 times sine theta gives you sine theta over what? Another sine theta. Excellent. What is cosine theta over sine theta? Cosine theta over sine theta is cotangent theta. Plus sine theta cancels out with sine theta, it gives you 1. Wow. Do you see the left side becomes cotangent plus 1? What I had on the right side? On the right side, I had also cotangent theta plus 1. Do you see both sides becomes the same? Do you see it as an identity? I told you that both sides of the identities, they are the same. Then a check mark. Yes, this equation represents an identity. If it's a multiple choice problem, your answer is yes. Correct? Another example, number 2. Again, same kind of instruction. Verify that the following equation is an identity, and the equation is given as a tan squared x. Is in the first problem they also gave it as a x? No, the first one was in terms of theta. Here they are using x instead of theta. Times 1 plus cotangent square x equals 1 over 1 minus sine squared x. Correct? This time, which side is complicated? You see, your left side is complicated. I'll leave alone the right side and I'll work only with the left side. First thing first, I will distribute tan, correct? It to the parentheses, which gives me tan square x plus tan square x cotangent square x. That's the first step when you distribute. Now I'll rewrite everything in terms of sine and cosine. Tan squared x means sine squared x over cosine squared x. Plus, again, tan squared x means sine squared x over cosine squared x. Times cotangent square x means cosine square x over sine square x. Or you can go another way, tan square x, cotangent is 1 over tan. You can write that way. Anyway, these are canceling out each other in both ways. Then you end up with sine squared x over cosine square x plus 1, correct? Plus 1. Sine square x over cosine square x again means tan square x plus 1. Now, look, tan square x, instead of tan square x, I have an identity that 1 plus tan square x equals secant square x. correct? Then instead of 1 plus tan square x, I can write secant square x. And secant is the reciprocal of cosine, correct? Then I can write this side as this thing as a 1 over cosine squared x. Correct? I can rewrite this as a 1 over cosine squared x. What I have on the right side? On the right side, it was given as a 1 over 1 minus sine squared x, right? Okay, what is 1 minus sine squared x? 1 minus sine squared x is cosine squared x. Then you see your left side, which is 1 cosine squared x. Also, this side becomes 1 cosine squared x, right? Because 1 minus sine squared is cosine. Then you can say the given equation is an identity. Correct? One more complicated one. I'm telling it's complicated, but when you practice with those identities, they are actually fun. They are not difficult. Tan x minus cotangent x over sin x cosine x equals secant square x minus cosecant square x. Correct? First thing, because here I have sin x cosine x, I'll try to make these two as a two separate fractions. I will rewrite as a tan x over sin x cosine x. Why I'm doing? Because I can see if I write tan x as in terms of sine and cosine, I can simplify this fraction. Minus cotangent x all over sin x cosine x. I'll keep the right side, I'll leave alone the right side. I'm only working on the left side. Now, replace tan in terms of sine and cosine. Tan is sin x over cosine x. Then all over, what do you have in the denominator? Sin x cosine x. Minus cotangent is cosine x over what? Sine of x. All over sin x cosine x. Simplify. It's a complex fraction. It means the numerator, which is sin x over cosine x, times, flip the denominator. Your denominator actually is sin x cosine x over 1. To flip it, it becomes 1 over sin x cosine x. Minus, do the same thing here, cosine x over sin x, times 1 over sin x cosine x. Start simplifying if it's possible. You see, sin x cancels out with sin x. What left? 1 over cosine x times cosine x, which gives you 1 over cosine squared x. Minus, here cosine cancels out with cosine, 1 over sine squared x. Correct? 1 over cosine square is secant square x. Minus 1 over sine means cosecant square x. Do you see The right side is also secant square x minus cosecant square x. Your right side is the same. It's given as a secant square secant. Why my pen is again moving like crazy? Secant square x minus cosecant square x. It was given. You see the left side and right side is the same. Then it proves that the given equation is an identity. Correct? One more, then I'll stop the lecture. This section has only practice, no extra lecture. Cosine x over 1 minus sine x equals to 1 plus sine x over cosine x. Let me tell you something. Every time that you see 1 minus sine x or cosine x or 1 plus sine x or cosine x, multiply your fraction with the conjugate of this. If it's 1 minus sine x, the conjugate of 1 minus sine x is 1 plus sine x. Multiply your fraction with that. Work only with left. Then I'll do this. 1 plus sine x over 1 plus sine x. I will multiply this fraction, the left side, which is cosine x over 1 minus sine x. I'll multiply it with this, with the conjugate of denominator. Those of you that you had math classes, immediately you know what does it mean. Keep the numerator in this form, cosine x times 1 plus sine x. Multiply the denominator. Do you remember this formula, the difference of squares? X squared minus a squared, which is equal x plus a times x minus a, right? Do you see that? The denominator is x plus a, x minus a. Then instead you can write as a square of the first, which is 1 square, minus the square of the second, which is sine squared x. 1 square is always 1, right? What is 1 minus sine square? You can replace 1 minus sine square as a cosine squared x, right? Then write cosine x times 1 plus sine x all over 1 square is 1, 1 minus sine x square. Instead, you can write what? Cosine square x. One of the cosine x cancels out with one of them. You end up with 1 plus sine x over cosine x. What do you have on the right side? It was given as a 1 plus sine x over cosine x. It means the given equation was an identity. I'll stop the lecture here. See you all in section 5.3.